Hey folks, so we've been working on this whole learning to subtract thing for a few years now, most likely, and sometimes it can get a little bit complicated, especially when it looks like subtraction can't happen. So if we look at the ones place in this expression, it says that it wants us to have 0 ones and then take 8 ones out of that. Well, if I have nothing to take, then I have nothing to take. Except for I don't have nothing to take because the number's not just a ones place number. It goes to the thousands. So this is where we start to learn how to ungroup from one place value and regroup into another. We're moving our values around without changing the full value of the number. We used to call it borrowing, although it's not exactly borrowing because we're not going to precisely put it back. There's a couple of different ways that we can approach this. So let's take a look at one on the right. If I can't take 8 out of the 0, then I'm going to have to start moving to greater place values. I'm going to move and I'm going to move and I'm going to see, oh look, I see there's 6,000 in this number. So what if I take 1,000 out of that and I'm going to redistribute it or regroup it. I'm going to take 1,000 out, so that's going to leave me with 5,000, and that 1,000 can be thought of now as 10 hundredths. 10 hundredths is the same value as 1,000. Well, that's awesome, but it's not going to help me in the tens or the ones place yet. So I'm going to leave a bunch of these hundreds here. I'm going to take one of them. I'm going to leave 900 behind. And if I take 100 and I put it in the tens place, now I've got 10 tens because 10 groups of 10 is 100. Again, all I'm doing is redistributing or regrouping. I haven't changed the value of that 6,000. I'm just moving some of it over. Well, that's great for the tens place, but I still need some ones to be able to subtract 8 from. So how about I take one of these tens and I'll leave 9 of the tens behind, and if I have one group of tens, then I have 10 ones. From here on in, I can just use that regrouped number, which is 5 thousands, 9 hundreds, 9 tens, and 10 ones, which is still 6,000, and do my thing. 10 take away 8 is 2, 9 take away 4 is 5, 9 take away 3 is 6, and 5 take away nothing is 5. That's one way to look at this, and I would call that sort of the traditional algorithm, the traditional way. Another way would be if we wanted to break this apart all at once. So here's how that would look. I have 6,000, and again, I know I'm going to have to redistribute or regroup that value to be able to subtract 348. So that we can see the subtraction on paper. So what I'm going to do is just redistribute it right from the get-go. I know I'm taking 1,000 away here, so that leaves me with 5,000. I'm going to take the largest number of hundreds that I need without taking it all, which is 9 hundreds. That leaves me with 100. Well, if I've got 100 tens, I'm going to take 9 out of those 10 tens. That's what I have, 10 tens. And then that leaves me with 10 ones at the end. Again, 5,000 plus 900 plus 90 plus 10, 6,000. Did we do anything differently? Yeah, we thought differently. But in the end, we end up with the same difference. In a problem like this, you know, it doesn't really matter which way you go. Whichever way makes the most sense to you. What if we look at it? So here we have 50,821, take away 3,617, and we're ready to go to town. Immediately I notice in the ones place I have 1 take away 7. Well, if I have 1 of something, I can't take 7 from it. So let's do this digit by digit style. the way we did for the first problem in the last slide, and we'll take 10 from here and we'll bring it over here. Well, 10 ones plus 1 1 means I've got 11 ones. One of the most common mistakes is people just regroup that 10 and forget about what's there already. Well, we already had 1. 10 plus 1 is 11. And now I'm good to go, at least for a while. If I have 11 take away 7, that's a difference of 4 in the ones place. 1 take away 1, difference of 0 in the tens place. 8 take away 6, haha, difference of 2. My brain skipped ahead. In the hundreds place. And now I get to the thousands place, and I am again presented with this conundrum. If I have no thousands, I can't take 3,000 away. So I'm going to have to ungroup from the next place value to the left from the next greatest place value. When I regroup, that one 10,000 becomes 10 thousands. If I have 10 thousands there now, and I take away 3 of those thousands, that leaves me with 7,000 different in that place, and 4 in the 10,000th place, take away nothing, leaves me with 40,000 in this place. So that's one way to go here. And you know what? It works. If you want to try regrouping all at once before, you can do that too. You do what works best for you, as long as you can get an accurate result. And if you're not sure how accurate it is, remember you can always estimate. So I look at my top number here and I say, 50,821 is kind of close to 51,000, and 3,617 is kind of close to 4,000. So I could really quickly say to myself, okay, yeah, this probably isn't even a really good estimation because I'm still regrouping. But it does show, oh, yeah, it's going to be about 47,000, and in fact, it is about 47,000. So this estimate makes me happy. I can feel pretty accurate. All right. Take your time with ungrouping and regrouping. Don't be afraid to check your work with a calculator or with a friend, because you want to get good at it, not just get one problem right or one worksheet right or one test right. You want to be good for life.